MaxLinear is a company that has technology and innovation in its DNA. MaxLinear has a unique capability of integrating analog and digital design on the same chip. Because of that, we have developed very interesting technology in the communication space. We have focuses on broadband access. As we speak, we have introduced the latest device called Puma 8. Connectivity is another one of our business units, and we are leading the way on Wi-Fi 7. Yes, in the optical infrastructure domain, we have developed the world's first 5nm fully integrated CMOS PAM4 DSP. Another area that we focus on is enterprise and data compression. And in that space, we have recently released to production Panther 3. One last area that we focus on is the 5G access. We have several solutions, but the latest one that we worked on is a fully integrated chip for ORAN, which is a new standard that is developing for communication to the house through wireless medium. As you can see from the list of products, they all present very critical challenges in terms of communication and high frequency analysis. To simulate accurately all the oscillation frequencies that are in the design, their interaction, how they can interfere with each other, they are all very important aspects for us. Because of that, EMX and clarity play a big role in these designs because allow us to determine early on if there are issues caused by having all these radios functioning at the same time on a single die and whether they create interference with each other. So with the cost of silicon going through the roof in FinFET technology, it's become ever more important to be able to predict exactly what the chip functionality is and whether any of the unwanted behavior will show up when the silicon comes back. And some of these phenomena are very difficult to simulate, and EMX is one of those tools that have worked very effectively and efficiently since it started because it allows you to really see what the interactions are between different parts of the chip and how the oscillations move across the traces. Our packages are quite sophisticated, and EMX capability is at the chip level. So now we find ourselves to have to get to the next step, which is co-simulating the die with the package and the package with the board. And that is what Clarity provides us with. In order to bridge that gap, that's why we use these tools, EMX on the chip level and Clarity at the board and package level. Both of them give us this insight that allow our designers to identify issues early on in the design and direct them to make a better product.